All right. Hopefully we're here. Hello? All right. Yeah, okay, we're here. Let's see, let's get set up. I'm feeling a lot better this week. I'm no longer sick. Looking at 2017. Start with AB this year, or today. Oh, come on. College board, please work. I got 2 viewers. Very cool. Very cool. Welcome, welcome. Well, we usually start at 11:05, so 5 minutes in. I don't know how long I'll go today, but usually I try to get done with half a year. I mean, theoretically, if I'm going at AP pace, it should be 15 minutes per question. So I should get done with about 4 questions. And then I usually do both the AB and the BC version of each test. There's a lot of overlap, so it's easy, but I shall pull up my calculator. I might do one of these like with how to do it on Desmos, but I'll keep showing my TI-84 for now because I think it's still pretty common that people use a TI-84. The techniques transfer over pretty well to Desmos. All right, and it seems you can see it on stream, which is good. First question here. All right, I guess I'll get started. Well, welcome to the people. Oh, 3 people watching. Wow, this is a great turnout. All right. Welcome, welcome. So, feel free to ask questions in chat or to like if there's particular problems you want to go over. I'd probably rather work on those than just the FRQs. But all right, a tank has a height of 10 feet. The area of the horizontal cross section of the tank is at height h feet is given by the function a, where a is measured in square feet. The function a is continuous and decreases as h increases. Selected values of a of h are given in the table. Use a left Riemann sum. Let me make sure you can actually see it correctly here. Yeah, that seems fine. Oh, 4 people. Wow. Left Riemann sum with 3 subintervals in the table to approximate the volume. Okay. This is, again, 2017. AB. All right, well, this should just be the integral of the cross-sectional area, basically. That should be the volume. So it will just be I guess I should write it down here. Left Riemann sum, so 50.3 times 2 plus 14.4 times 5 plus 6.5 times 10, not times 10, oh my gosh, times 3, the gap, plus 6.5 times 5. And that's supposed to be the integral from, approximates the integral from 0 to 10 of a of HDH. I think that's right. And let's see. 50.3 times 2 plus 14.4 times 3 plus 6.5 times 10. 208.8. What's the units of measurement? Well, A is in square feet and H is in feet, so it's going to be feet cubed. Right, this is feet squared, and this is feet. Does the approximation in part A overestimate or underestimate the volume of the tank? Well, it's a left Riemann sum on a decreasing function, so it overestimates it. I had a student tell me that they always overestimate. I think it's actually very common historically to overestimate on the AP test. Overestimates because left Riemann sum overestimates decreasing functions. I guess, well, yeah, decreasing functions. All right, the area in square feet of the horizontal cross-section at height h is modeled by the function given by whatever. Based on this model, find the volume of the tank. So just a different problem. Here, they're telling you the square feet, so we're telling you the cross-sectional area. So the volume is going to be the integral from 0 to 10 of that. I would dump f into my calculator. So let's go to y equals. y1 is going to be 50.3 over paren e to the 0.2h x plus x, right? And then quit out math 9 integral 0 to 10 alpha trace y1 dx. I'm going through this kind of fast. I might make some errors, but we'll see. 101.325. That seems way different than the one I got up there. Okay. All right. I guess that's what it is. D, water is pumped to the tank. When the height of the water is 5 feet, the height is increasing at a rate of 0.26 feet per minute. Using the model from part C, find the rate at which the volume of the water is changing with respect to time. So here we know the volume. This one's actually kind of tricky. The volume is the integral from 0 to h of f of whatever, f of x dx. They're telling me that when h is 5, dh dt is 0.26. And this, it's like a related rates problem. If you differentiate this one, assuming that v and h are both functions of, that v is a function of h, you get dv/dh, v and h are functions of t. You get dv/dt is what's the derivative of this guy. FTC says that's f of h, but then you got chain rule on a dh dt. That one's a little confusing. And then now you plug in at 5. At 5, we don't know dv/dt. At h equals 5. But, I mean, f of h is just f of 5. And then dh dt is going to be 0.26. All right. And you just calculate that. To get f of 5, you do alpha trace. y1 of 5 times 0.26. And that's 1.694. Box my answers. And let's just check how far off I am. I'm going very fast, and I do make more errors the older I get. But let's see. I apparently completely miscalculated the first one. I'll check that in a second. But I tried to do the right thing. 101.325 was correct for part C, and part D was correct. I just goofed something up when I plugged in my calculator. Let's see, just check part A again. 50.3 times 2, yeah. 14.4 times 3, yeah. And then I was wondering what could have gone. 6.5, oh, times 10, see? Silly mistake. Should have been 5, of course. I even wrote down 5. So just wrong number, 176.3. But this is, again, it's kind of a good mistake to make in the sense that you can see here like how many points I get taken off. I get taken off 1 point for getting the approximation wrong. So I still get 8 out of 9 on this. So not a huge deal even if you mess something up like plugging into your calculator. Right, what I did was I I wrote it down correctly. I just didn't plug in. I plugged in 10 to my calculator instead of 5. All right, let's keep going. Question number 2. I'll pull it up in a second. When a certain grocery store opens, it has 50 pounds of banana on a display table. Customers remove bananas from the display table at a rate modeled by whatever. So I'm going to dump things in my calculator right now. Y is 10 plus 0.8 x sine of x cubed over 100. Always a good habit when you plug in sine, just make sure you're in. Oh, I'm in degrees mode. See, gotta be in radians mode. All right, and then g is 3 plus 2.4 ln of x squared plus 2x. And notice that only turns on after 3, so just be careful about that. All right. So G is an outflow. G is an inflow. F's an outflow. All right. How many pounds of bananas are removed from the display table in the first 2 hours? That's ignoring that one. Well, it doesn't really matter. That's just the integral from 0 to 2 of f t dt. So on my calculator, that's going to be math 9, 0 to 2, alpha trace y1 dx, 20.05 pounds. 051 pounds. Okay, cool. Next one, B, find f prime of 7. Okay. Oops, that's math 8. Math 8, d dx, alpha trace y1, 7, and that's going to be negative 8.120, negative 8.120. Definitely should not be calculating these by hand. What does this mean in the context of the problem? So I have to read this again. F is already a rate, so you can say, maybe I'll just type it out. The rate at which bananas are leaving the table or maybe I'll start with at t equals 7. The rate at which bananas are leaving the table is decreasing, and I'm running out of space here. Let me make this a little smaller. Oh my gosh, this is so frustrating. It is annoying I don't have any place to write this. It is decreasing, let's do this for a second and put it somewhere else, at a rate of negative of 8.12 bananas per hour. Let me double check that. And try to put this in a slightly better position. That's just so frustrating. Okay, let's do that and move it over here so you can. There we go. Let me just double check that's correct. Oh, I mean, not looking at the answer, but pounds per hour, not pounds per hour, not bananas. And maybe you say hours here. F is a rate. Yeah. All right, cool. All right, C is a number. I need to add another page. Okay, is a number of pounds of bananas increasing or decreasing at t equals 5. So notice at 5, that's in both things. So people are putting bananas on and taking bananas off. Sometimes it helps to actually come up with this function, A of t. That's the amount of bananas at time t, or pounds of bananas at times t. And we know A of 0 is 50 because it says so. There are 50 initially. And then A prime of t, Well, that's just how much they're adding on, and then you take off how much is being taken away. That's G minus F. All right, that's a good little setup for C and D. C is asking, is A prime of 5 negative, basically, right? Is it increasing or decreasing? So A prime of 5 is G of 5 minus F of 5. And that is, my calculator says, oops, alpha trace y2 of 5 minus alpha trace y1 of 5. And that's negative 2.26, and that's less than 0. So it's decreasing. D, how many pounds are at 8? Well, A of 8 is going to be, well, I know by net change theorem, right? It's A of 0 plus the integral from 0 to 8 of A prime of t dt. And that's 50 plus the integral from 0 to 8 of g of t minus f of t. Because that's what A prime was. And I dumped that in my calculator. 50 plus math 9, 0 to 8. Alpha trace g minus f. Okay, y2 minus y1 dx. I think that works. Man, how slow can my calculator be? Jeez. Did I like type something in wrong? Ugh. 41.84. Okay. 8435. Okay, let me check that. 844. All right, let me box my answers. We got D there. We got C there. I mean, not much to say besides C. And then we have B and A. All right, let me check the answer key. 20.051 pounds are removed. The explanation for B, the rate at which banana is being removed is decreasing. Yep, pounds per hour. Yep, got the units. It was negative, so it's decreasing at 5. And then 20, I somehow did it completely wrong. A of 8 I did wrong. Ah, that got me. Yeah, okay, oops. This 0 to, I knew they'd get me with that. Remember that G only works from 3 up to 12. So this was actually wrong. This needed to be the integral from 3 to 8 of G of t dt minus 0 to 8 f of t dt. That's annoying. So if you recalculate that, so there's the correct, what? Oh, because it's negative. It's that one, and then plus math 9, 0 to 3 to 8. Yeah, that one I'm going to get 19.6. Oops. Sorry. This first one's wrong. Because that one, the first one I typed in was F. That one was correct. This needs to be G, sorry. So it's this guy plus math 9, 3 to 8 of y2. 23.34. That's the correct answer. Number 7. All right. Cool. Let's go on. Let's see. All right, part 3. Question 3. For people who are like joining, again, this is AP Calc AB 2017. Where am I? Here we go. All right, The function is differentiable on the closed interval -6 to 5 and satisfies f of -2 to 7. The graph of f prime, the derivative consists of a semicircle and 3 line segments. All right, let's find f of negative. Oh, I need to turn off my calculator. Let me do that. There you go. It's gone now. Okay, find f of -6. Well, net change theorem says f of -6 minus, or f of -2 minus f of -6 is the integral from -6 to -2 of f prime of x dx. This is just one of the things you got to get used to. If you know the derivative, to find, you can find the difference between two values, like -6 and f of -2, by using FTC basically. And if you plug in here, we get 7 minus f of -6. I mean, what's this integral -6 to -2? That's just this area here, which is 4. It's a 4 by 2 triangle. Sometimes it is helpful to go in and label the areas. I do find that helpful, actually. This is an area of 1. This is an area of 2. And then each of these semicircles is -pi. Because a whole circle is 4 pi. Yeah. All right, anyway, this integral is 4, and so you can get f of -6 is 3, I believe. All right, so that's my answer there. I did f of 5 as well. Maybe I should move this work down. I don't do that. Okay, this is A. And then f of 5 minus f of -2 is the integral from -2 to 5 of f prime of x dx. And that's f of 5 minus 7 equals -2 to 5 is -2 pi plus 3. So 3 minus 2 pi. And so f of 5 is 10 minus 2 pi. I'll check that later on, but I think those are right. B, on what intervals is f increasing? Well, f is increasing, I'll type this out. F is increasing when f prime is positive. And f prime is positive on the graph from -6 to -2 and 2 to 5. Graph says this is -6 to -2 and 2 to 5. This is at. How are we on? All right, C, find the absolute min of f on -6 to 5. That's always a pain in the butt. Absolute min is going to be a candidates test. So to find absolute min, you got to use the local mins. You could just use all the critical points, but it is better to use the local mins. Local mins are where this is f changes from decreasing to increasing, and that's the same thing as f prime changing from negative to positive. So where does that occur? That occurs at 2. Yeah, so 2 only. 2 is the only local min. Notice it's crossing from negative to positive here. Okay, and so you make a table. And it wants on -6 to 5. So you got to plug in -6, got to plug in 5, got to plug in 2. And f of x. All right, -6 we already did, that was 3. 5 we already did, that's 10 minus 2 pi. And then 2 is supposedly a local min. F of 2 is -2 pi. How do I know that? F of 2 minus f of -2, oh, sorry, it's not -2 pi, I lied, is the integral from -2 to 2 of f prime of x dx. This area is -2 pi. If you look at up here, that's -2 to 2, -2 pi. And then f of -2 is 7, so we get 7 minus 2 pi. And here they're kind of being annoying because you need to know that 3 is less than 7 minus 2 pi or whatever, which is irritating. So what that should be is, I mean, definitely 7 minus 2 pi is less than 10 minus 2 pi, of course, because it's 3 less. And then 7 minus 2 pi, that is less than 7 minus 6, because 2 pi is a little more than 6, and that's 1, that's less than 3. So 7 minus 2 pi is the absolute max, absolute min. All right, justification is basically the table I'm making and talking about only local min. All right, let me check if anybody, okay. D, for each of f double prime of -5 and f double prime of 3, find the value, explain why it doesn't exist. F double prime of -5, that exists. So that's over here, and the slope of this line is 4 over down 2, or yeah, 4 over down 2, so that's -1/2. Remember, the slope of f prime would be f double prime. And then the other one that wanted was f double prime of 3. Oh, this one's a stupid problem. Yeah. So this one doesn't exist, but saying it is actually really difficult. F prime of 3 dne, and how do you say it? You be careful. I think what it says, because the limit as h goes to 0 from below of f of 3 plus h minus f of 3 is 2 minus 2 over h is going to be the slope on the left, which is 2. Now, how do you know that? It's a little unclear, but you might need to actually make like a piecewise function for f. I mean, to be like perfectly rigorous. And the limit as h goes to 0 from above of f of 3 plus h minus 2 over h is not -2. It's negative, at least. It's -1. So the limit h goes to 0, f of 3 plus h minus f of 3 over h dne. Notice you don't just get to say it's a corner. That's what you want to say, but you don't get to say that. All right, let's check my answers. A, 10 minus 2 pi. Right, 3, 10 minus 2 pi, yep. Increasing on -6 to -2 and 2 to 5. Yep. Yeah, see, you're probably allowed to get away with not checking -2, which is what I did. That's fine. And then D, -1/2. I probably should have explained how I got that, but whatever. Yeah, and this one's a bit tricky. I'll show you what they say. You might think, isn't it just a corner? Isn't that the whole point? But here's the answers they give, similar to what I said. All right. You check that the limit from the left doesn't equal the limit from the right, and it's a weird limit, right? It's a limit that shows up in the definition of a derivative. It's importantly not this. It's not the limit as x goes to 3 of f double prime of x. That's not the limit you're looking at. You're looking at this limit, which is different. This one actually is probably too subtle, I think. I think it's actually a bad question because it's a little too subtle. You will probably see in future FRQs after 2017, they don't ask this question anymore. This kind of question. Because they kind of painted themselves into a corner. Let's go on. Let's see. Potato problem, my favorite. Okay, at time t equals 4, a boiled potato is taken from a pot on a stove and left to cool in the kitchen. The internal temperature of the potato is 91 degrees Celsius, and the internal temperature of the potato is... This is a really weird thing for them to say, but you need it at some point. The internal temperature can be modeled by whatever. Okay, write the equation for the tangent line. Line tangent, you just need to find h of 0 and h prime of 0. H of 0 is 91, it says so. H prime of 0, well, that's dHdt when at t is 0. And that's negative a quarter times h of 0, which is 91. 91 minus 27. 64, negative quarter, that is 16. So negative 16. And now you have a slope and a point, right? It goes through 0, 91, and it has slope negative 16. So you can just write out that L of t is negative 16 times x minus 91, or x plus 91, or t times plus 91. Cool. That's the tangent line. That's always a good one to get in the habit of it. It is easy to write out the tangent line once you know the derivative and the slope. Now it wants you to approximate at t of 3, so the idea is that h of 3 is approximately L of 3, and that's negative 16 times 3 plus 91, which is negative 48, plus 91, 91 minus 48, 43. Right. I think that's wrong, based on my memory. Okay, maybe not. I think it's fine. Okay. B, use d squared h dt squared to determine whether it's under or over estimate. All right. Do I have enough room here? Yeah, I probably do. So d squared h dt squared, if you differentiate, is just negative a quarter dht. Right. I mean, if you expand this, you'd get that guy and then a constant. The constant goes away. And the common mistake is that derivative h is dht. It's not just 1. So you get dHdt here, and you want to plug that back in, basically, so you get 1/16 times h minus 27. Now, I do know that this is positive always. Why? Because of star up here. The internal temperature of the potato, h, is greater than 27. I might say that because star. All right, well, it seems like d squared h dt squared is always concave, or is always positive. That means h is always concave up on 0 to 3. So on a concave up function, a tangent line is an underestimate, just based on the picture. So the tangent line underestimates. I mean, you kind of already know this, right? Like if you think of the graph of what this potato temperature is, it's probably some exponential decrease. So if you draw a tangent line in, it should be underneath. It feels right. All right, C. An alternate model is given by that differential equation. Find expression for g of t. Okay, let's do that. So you get dg over g minus 27 to the negative 2, I guess, to the 2/3. I'll write it as a product. So I'll do g minus 27 to the negative 2/3 dg is negative dt. And now you integrate both sides. This one just got to use your power rule. It's 3 times g minus 27 to the 1/3 equals negative t plus c. And I solve. G minus 27 to the 1/3 is negative 3t plus c. Again, divided by c. Negative t over 3 plus c. And then cube root. g minus 27 is cube root of negative 1/3 negative t over 3 plus c, and then you add 27. G is 27 plus the cube root of negative t over 3 plus c. You got to find c now. We know that g of 0 is 91, so you can plug in. 91 is 27 plus cube root of negative t over cube root c. And now you subtract and you get 64 is cube root c. Whoa, that seems wrong. Did I do something wrong? Oops, I cubed root instead of cubed. My mistake. Silly. Undoing the 1/3 power is cubing. So I'll call it c minus t over 3 to the 1/3, to the cubed. I like that better. And here, let's fix that into c cubed. All right, c cubed, so c is 8. Sorry, 4. And now you can update this. G of t is 27 plus 4 minus t over 3 cubed. If you want to tie that up, you can. I think, if just memory serves correct, I think the answer is supposed to be something like they want 12 minus t over 3 like that, so they can add the fractions or something. All right, that seems right. And then based on this model, what's internal temperature? So G of 3 is 27 plus 12 minus 3 over 3 cubed. That's 27 plus 9 over 3 cubed, which is 27 plus 3 cubed, which is 27 plus 27, which is 54. All right, that's a nice one. Let's see if my answers are correct. Yeah, 43 degrees, 91 minus 16t looks good. Concave up under estimate looks good. Have the right solution. Yep, and 54 degrees. Looks awesome. All right. I'm doing 10 minutes per question. That's a great pace. I'm not making too many errors. Let's do another one. Let's do number 5. Okay, 2 particles move along the x-axis for 0 less than t less than 8. The position of a particle p at time t is given by xp of t is ln whatever. Okay, and then you have a different one at q. When is p moving to the left? Okay, moving to the left is the same thing as vp being negative. So you got to find vp. Vp is xp prime of t, and that's going to be 1 over t squared minus 2t plus 10 times 2t minus 2. And when is that negative? Well, got to make a sign diagram. Well, is that really what it wants? I guess, yeah. The bottom's always positive, though, which is convenient. Because t squared minus... Let's see, how do I want to say this, though? Let me move this down here. So I will just say... All right, so Vp of t we know is 2t minus 2 over t squared minus 2t plus 10. Let's see. Vp of t is less than 0 if... Sorry, I guess. If Vp of t is less than 0... Or I'll do the double arrows. So it's equivalent to saying that 2t minus 2 over t squared minus 2t plus 10 is less than 0. And that's equivalent to, you can just multiply through by the bottom because the bottom isn't always positive. Importantly, t squared minus 2t plus 10 is equal to t minus 1 squared plus 9. And that's positive. So you can just multiply through by it and not affect the inequality. And that is the same thing as 2t is less than 2, and that's the same thing as t is less than 1. Cool. That's what it is. So the answer is 0 to 1. All right, B. For 0 less than t less than 8 phi times t, where the 2 particles travel in the same direction. All right. Well, let's find when VQ is moving to the left. So this occurs exactly when t squared minus 8t plus 15 is less than 0, and you can factor that, and that's t minus 3t minus 5. And that occurs when t is between 3 and 5. All right. Cool. So you can kind of think of a little sign diagram here. Here's VP. It goes negative, positive, and then this is 1, and then VQ at 3 and 5, it goes positive, negative, positive, like that. So same direction, 1 to 3, and 5 to 8. So VP and VQ are positive, are both positive on this one, and nowhere and never both negative. All right, that's my answer. All right, part C. Find the acceleration of q at 2. All right, so we know AQ of t is VQ prime of t. And that's going to be just 2t minus 8. And it wants to know at 2, so AQ of 2 is negative 4. Is the speed of the particle q increasing, decreasing, or neither at time 2? So we know that acceleration is negative. I also need VQ of 2. And VQ of 2 is, VQ's up here, right? So that would be 4 minus 16 plus 15, which is positive. Okay, so they work against each other. They have their opposite signs, VQ of 2 and AQ of 2 are opposite signs. So Q is slowing down. All right, part D. Was there anything else it asked? No, okay. Find the position of the particle Q the first time it changes direction. So let's find when it changes direction. That's when VQ is 0. VQ equals 0 is at, that implies that t squared minus 8t plus 15 is 0. And that implies that t is 3 or 5. So this implies 3 is the first time. Technically, you do need to say that VQ of t is less than, all right, greater than 0 on 0 to 3, and VQ of t is less than 0. Like you have to, actually have to switch signs, right? Can't just equal 0. So you need to additionally say something like this. VQ of t is less than 0 on, what was it, 3 to 5. Q switches, changes direction. All right. That's the first time it changed direction, and it wants the position. So we know XQ of 0 is 5. I'll use that. We want it at 3. So XQ of 3 is going to equal XQ of 0 plus the integral from 0 to 3 of VQ of t dt. And that's going to equal, it was 5, right? XQ of 0 was 5. Yep, 5 plus the integral 0 to 3 of this quadratic, t squared minus 8t plus 15. That's just a computation. T cubed over 3 minus 4t squared plus 15t from 0 to 3. Don't include the 5. And that's 5 plus 27 over 3 is 9 minus 4 times 9 is 36, and plus 30, and then minus 0. And that's going to be 5 plus negative 27 plus 30 is, so 9 minus 36 is negative 27. That's the same thing as 5 plus 3, and that's 8. So I think that's the answer. Okay, let's see how badly I did that. I feel like I made a mistake. Let's check. 0 to 1 looks good. 1 to 3, 5 to 8 looks good. Speed is decreasing, looks good. I did make a mistake. I 15t. Oops. Yeah, made a small issue there. I thought that was, wait, 30? Where did that come from? That's so weird. 45, of course, not 30. Let me write that in pink. I don't know how I made that error, but whatever. 45, obviously, and 5 plus not 45, not 3, but 18 is 23. All right, and that's the correct answer. Yeah, I do that. I do that more and more these days. Like, somehow just completely fail to execute when plugging into a formula. I guess we can do part 6. Right. Give myself some room like this. Okay. Let f be the function defined by f of x is cosine 2x plus e to the sine x. Let g be a function given the table. And then let h be given by the graph. Oh, they're really being funny here. Okay, so 3 different functions, different ways of doing it. Find the slope of the line tangent to the graph of f at pi. That's just asking of f prime of pi. Well, f prime of x is negative 2 sine 2x, chain rule, plus cosine of x e to the sine x. And so f prime of pi, sine of pi is 0, and cosine of pi is 1, negative 1. So minus 1 e to the 0, so negative 1. Let me just double check that. 0, yeah, and then 1. I think that's right. Okay. B, let k be the function defined by k of x is h of f of x. I'll see that down here. Find k prime of pi. Well, k prime of pi is going to be, by chain rule, h prime of f of pi times f prime of pi. And, okay, that's h prime. And what is f of pi? I guess I'll do that down here. F of pi is cosine 2 pi plus e to the sine pi, which is cosine 2 pi is 1, so 1, and then sine of pi is 0, so 1 plus 1 is 2. So this is h prime of 2, right? F of pi is 2, I just figured that out, times negative 1. H prime of 2, look at the graph, h prime of 2 is negative a third. Right, because this slope is negative a third there. Really concerned with f prime of pi. I feel like it's wrong. Let me just think for one more second. Yeah, negative 2 sine 2x, and then we have a e to the sine x. And that would be plugging in cosine out front, so negative 1 at pi. Okay, I'll go with it. All right, C. Let m be the function defined by g of negative 2x times h of x, find m prime of 2. So m prime of 2 is going to be, or m prime of x, I'll do that one first, is a chain antiproduct, which is very annoying. A product in a chain, very annoying. So g of negative 2x times h prime of x plus negative 2g prime of negative 2x, that's a chain rule, and then h of x. All right, now m prime of 2 is g of negative 4, h prime of 2, minus 2g prime of negative 4, h of 2. All right, let's see that. Let's list these out. G of negative 4, g prime of negative 4, h of 2, h prime of 2. G of negative 4 is in the table 5. G prime of negative 4 is from the table negative 1. H of 2 is negative 2/3. And h prime of 2 is negative 1/3. Seems like it. That's so weird. Okay. And so that's 5 times negative a third minus 2 times negative 1 times negative 2/3. It seems so wrong. Negative 5/3, triple negative, wow, minus 4/3. So negative 9/3, which is negative 3? Yuck. Okay, I'll go with it. And then D. I should check my work on that one again. Let me think. Okay, I guess I'm okay with the. Oh, let's do D. Is there a number C in the closed interval -5 to -3? Sorry, somebody's messaging me. Ugh, 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 ugh. Okay, sorry about that. This is the danger of streaming when I need to schedule things as well. All right. Is there a number C in the closed interval? Blah blah. This is like an MVT problem. So, well, let's just hope the interval that they're telling me is like accurate. So does it say G is differentiable? Okay. So G is differentiable on just everywhere. Okay. So -5 to -3. So MVT applies. If you're differentiable on the closed interval, you're differentiable on the open interval, and you're continuous on the closed interval. So you don't really need to say that, though. But you do need to give some reasoning why MVT applies. So there is a C in -5 to -3. Such that G prime of C is G of -3 minus G of -5 over -3 minus -5, and that's going to be G of -3 is 2, and then G of -5 is 10. -3 minus -5 is 2. And hopefully it's -4. Yeah, okay. So -8 over 2, which is -4. Done. You might be thinking, wait a second, they tell me G prime. Can't I use IVT on G prime? And the answer is no, you cannot. Because there's no guarantee that G prime is continuous. All it says that G is differentiable, its derivative might not be continuous. Now, okay, what is lame is that it is true that derivatives do satisfy the IVP, the intermediate value property, so you actually can do that, but that's not a simple theorem. And it's not one that's known in AP Calc. So it is proper to do it using MVT and not, quote, the intermediate value property for derivatives. I should check my answers because I feel like this is horribly, horribly wrong, but we'll see. -1, a third, -3, -4, -4. Wow, I did it. Okay, cool. I guess that's it. I guess I did it correct. Dang. All right, I seems like going out on a limb there. Yeah, just no. I mean, here the deal is just got to know your derivative rules using like letters, right? F, G, and H. Sometimes students are happy to do it, happy to chain in product and whatever, if they are concrete functions they know. But as soon as you start, oh, it's any function, it's F. They're like, I have no idea anymore. And that's something to just get over. Actually know what the theorems say. And also observe what your muscle memory is doing, right? It's important to, whenever you're doing something, like, observe what rule you are following. But aside from that, I guess we will stop there. Thanks to everybody who watched. Again, I'm really slacking on putting up these videos. I might do that this weekend. I don't know, but I should put them up like hopefully like a week before the AP exam at least. But thanks for coming, and bye for now.